In this session, I explained data encryption standards. Or data encryption standard means DES was introduced by the National Institute of Standards and Technology. DES means data encryption standards and AES means advanced encryption standards. Both are symmetric block ciphers. The basic difference between DES and AES is that in DES, plain text block is divided into two halves before the main algorithm starts, whereas in AES, the entire block is processed to obtain the ciphertext. So in these sessions, I explains the DES means data encryption standards. So, data encryption standards DES is the symmetric block cipher which encrypt a 64-bit plain text into 64-bit ciphertext. The DES was introduced by the National Institute of Standard and Technologies in the 1970s. Initially, DES was only used in financial application, but later it was accepted as the cryptographic algorithm by other organizations too. Being a symmetric cipher, the same key is used in encryption and decryption process of DES. In this context, we will discuss the steps performed in DES, and we will also discuss the advantage and disadvantage of DES. So, being a symmetric cipher, the same key is used in encryption and decryption of DES process. First, I explain the encryption process of DES algorithm. So, in the encryption process, in step 1, the 64-bit plain text submit to initial permutation, which rearrange the bits to produce two 32 bits permuted block, which is called left plain text, or we can say LPT 32 bits, and right plain text means RPT 32 bits. So it is a process of step number 1. Now in step 2, there has 16 rounds of DES encryptions will be performed on this LPT and RPT with 56-bit keys. Now in step 3, after the 16th round of 32 bits LPT and 32 bits RPT are integrated, which forms a 64-bit block again, and then the final permutation is applied to this 64-bit block to obtain the 64-bit ciphertext. So this is a simple encryption process. I again repeat this process for better understanding. So in step 1, 64-bit plain text submit to initial permutation, which rearrange the bits to produce two 32 bits permuted block, which is called left plain text means LPT of 32 bits and right plain text means RPT of 32 bits. Now in step 2, 16 rounds of DES encryption will be performed on these LPT and RPT with 56 bits of key. Now in step 3, after the 16th round, the 32 bits LPT and 32 bits RPT are integrated, which forms 64-bit blocks again, and then the final permutations is applied to this 64-bit block to obtain the 64-bit cipher text. So in the decryption process, the same data encryption standard algorithm used for encrypting the plain text is also used to decrypting the ciphertext, but the algorithm is reversed, such as the initial and final permutation events are reversed. Even the sequence of the subkey applied in 16th round of DS are also reversed. So this is the simple process of encryption and decryption in DS algorithms. So now I have discussed on rounds in data encryption standards. Now I will discuss the process that take place during the 16 rounds of DES algorithms. Each round of DES performs the same functions. So here I have explained the steps of functions performed in each round of DES algorithm. So first step is key transformations. Second step is expansion permutations. Third step is S-box substitutions. Next steps is P-box permutations, and final steps is XOR and Swap. So this is the steps. With the help of these steps, we can perform the encryption in plain text. Now, I have explained these steps in details. So, our first steps is key transformations. Earlier, I have discussed that the initial key size is 64-bit, which is reduced to the 56-bit key. This is done by discarding every 8 bit from the 64-bit key. So for each round of DES, this 56-bit key is used. In the key transformation steps, this 56-bit is transformed to the 48-bit key. Let's see how this possible. So the 56-bit key is split into two halves. Each half is of 28-bit. Now, a left circular shift is implemented on both the halves, which shift the bit in two halves by 1 or 2 positions, depending on the order of the round. If the round number is 1, 2, 9, and 16, then the left circular shift is done by 1 position. Else, if any other order number is encountered, the circular shift is done by 2 positions. After the left circular shift, both the 28 bits halves are integrated and permutation is performed on a 56-bit key. And from this permuted 56-bit key are performed in 48-bit subkey is selected. As the key transformation steps involve permutations along with compressions of 56-bit key to 48-bit subkey, it is also called compression permutations. So the key transformation steps provide a different 48-bit subkey for each round of DES. Now I have explained expansion permutation. In the first steps of encryption, during the initial permutation of DES, the 64-bit plain text is permuted and we have 32-bit LPT and 32-bit RPT. Now, the expansion permutation is performed on the 32-bit RPT, which transforms it from 32-bit to 48 bits. Remember, here we have only select 32 bits RPT. The 32-bit LPT is untouched during this process. For expansion, the 32 bits RPT is divided into 8 blocks, where each block is of 4 bit. Each block of 4 bit is expanded to block of 6 bit, as you can see in the figure. The extremes 2 bits of the blocks are repeated and the middle 2 bits is passed on as it is. Means the first and fourth are assumed for the next blocks and remaining 2 and 3 blocks bits is same. Again, I have explained the extreme 2 bits of the block means this first and fourth are repeated and the middle 2 bits means 2 and 3, 2 bits is passed on as it is. So this is the steps of expansion permutations. Once again, I have repeated this process. So in expansion, the 32 bits RPT is divided into 8 blocks, where each block is of 4 bit. Each block of 4 bit is expanded to block of 6 bits. As you can see in the figure, the extreme 2 bits means this first one and fourth one of the block are repeated, means this is repeat here and this 4 is repeat here. And the middle 2 bits means second and third is passed on as it is. So this is the simple process of expansion permutation. After expansions, now the 48 bits RPT is XOR with the 48-bit key, and the result is 48-bit blocks is transferred to the S blocks substitutions. So this is the simple process of expansion of permutations. Now I have explained the S box substitutions. The input to S box is 48-bit resultant block of expansion permutation. In S block substitutions, the input 48-bit block is transformed to 32 bits block. But the question is how? 48 bits input block to S block substitutions is divided into 8 block of 6 bit each. and is provided as input to 8 substitution box, also called as S blocks. Each S box has an input of 6 bit and its output of 4 bit. Each S blocks is considered as the table which has 4 rows, means 0, 1, 2 and 3, and 16 column, means 0 to 15. So question is why 4 row and 16 columns? Because from the 6-bit input to S blocks, the two extreme bits are used to determine the number of rows. So 2 bits can form 4 combination of zeros and 1. So 22 bits are considered into 4 rows. The middle 4 bits are used to determine the number of columns. So 42 bits has occupied 16th column. Now we will see how the 6-bit input is transformed to the 4-bit output. For example, in this figure, you can see that input bit at position 1 and 6 is 1 and 0 that represent 2, which determines second row, and middle 4 bits means 0, 1, 1, 0 that represent 6, which determines the 6th column of S blocks. The value at the intersection of the second row and 6th column will represent 4 bit of output corresponding the S blocks. So, in our example, the intersection of the second row and 6th column is 13, means second row means 0, 1, 2. Second row and 6th column means 0, 1, 2, 3, 4, 5, 6 is intersects with the 30 bits. Here its 4-bit represent is 1, 1, 0, 1. So the output of S blocks 1 is 1, 1, 0, 1. Similarly, the remaining S blocks function will be carried out to the find the remaining 4-bit outputs. In this way, the 8 S blocks would generate 8 4-bit output blocks, which when integrated from 32 bits outputs. Now I have explained P box permutations. The 32 bits output obtained from S block substitution is provided as an input to P box. Here the 32 bits input is simply permuted and sent to the next steps. So the next step is XOR and Swap. As you can observe, so far we have been operating on 32 bits RPT of the initial 64-bit plain text. The 32 bits LPT is still untouched. Means we have performed key transformation, expansion permutation, S blocks and P box on 32 bits RPT. In these steps, the 32 bits LPT of the initial 64-bit plain text is XOR with the output of P box permutations. The result of the XOR is new RPT for next round, and the odd RPT is swapped with LPT. So the old RPT is now new LPT for the next round. And the old RPT is now new LPT for the next round. So I hope you can understand the XOR and swap. So here the process of a single round ends and next round start, which has the same functions. After 16 such rounds, the output of the 16th round undergoes the final permutations. The result of this final permutation is 64-bit ciphertext. So this is the steps of the encryption in DES algorithm. I hope you can understand these steps. Now I explain the advantage and disadvantage of DES algorithm. The first is DES has a 56-bit key, which raises the possibilities of 256 possible key, which make brute force impossible. Second is the 8 S blocks used in each round were not made public, and even it impossible for any to discover the design of the S blocks, which makes the attacks more impossible. Next is the number of rounds in DES increase the complexity of the algorithms. So it is the disadvantage of the DES algorithms. So however, the cryptanalysis attacks is easier than the brute force attacks on DES. So now I explain the key summary of this algorithm. DES is a symmetric block cipher. DES encrypt 64-bit plain text to 64-bit ciphertext. DES use a 56-bit key for encryption. Encryption and decryption algorithm is the same in DES, but the procedure of encryption is reverse while decryptions. 16 rounds in DES strengths of the algorithm. Each round has the same function, which involves key transformations, expansion permutations, S block substitution, P box permutation, and XOR and swapping. So this is all about the DES block cipher. So thank you friends watching this video. I hope you can understand the encryption and decryption process of the DES algorithm. Thank you.